So today we're going to talk about the circle. Not that we haven't seen this diagram a few 100,000 times this year. Nothing new here. The circle is the first of our conic sections. Chapter 10 is all about conic sections. And conic sections, as you recall, are the circle, the ellipse, the hyperbola, and the parabola. Those are our four basic conic sections. We also have the degenerate cases, as the line and the point. But we're going to start by looking today just at the circle. Circle, as you know, is defined as the locus of all points equidistant from a given point. That's from geometry years ago. So all points equidistant from a given point. A circle in a conic section is found when we intersect the conic section perpendicular to the axis of the conic section. And I'm not sure if I still have a conic section model for that. I used to. Maybe I don't anymore. I think it broke. Oh well. Yeah, it's if you look at the idea of a conic section, as you recall, the idea here is you have a double cone. Okay, and that cone has an axis that runs through it vertically, and a circle is what happens when a plane intersects that conic section perpendicular to the axis here. So that's a right angle. And that intersection then becomes a circle. So, okay. And I drew that very poorly, but you get the idea. I'm not really good at drawing that sort of thing. That's why I wanted an actual model. My artistic skills are sorely lacking. But that's the idea. That's where the conic section comes from. We know that any point on a circle xy is a given radius from the center of the circle. The same stuff we've been dealing with for years with circles. The regular equation that we learned back in Algebra 1 and reinforced in geometry and learned again in Algebra 2, so this is the fourth consecutive year you're getting this equation. One you should have fairly memorized is good old x minus h squared plus y minus k squared equals r squared. That's a standard form equation of a circle with center at hk and radius r. Nothing new about that. You've seen that a few times before. And again, we can generally find this equation fairly simply if we know the center of the circle and at least one point on the circle. Because if I know the center on the circle, if I know the center, I just plug that into the equation h and k. If I know any point on that circle, I can find the radius by just running distance formula between these two. And you may notice a distinct relationship between the equation of a circle, Pythagorean theorem, there's a right triangle, ABC, and distance formula. Distance formula is the square root of the equation of a circle. And they're all just fancy expansions of Pythagorean theorem. They're the same equation, just re-expressed in different ways. And here I could easily use distance formula. If I know a point on the circle in the center, I could easily use distance formula to find the radius. We find the equation of the circle. It's not too tough. What's more interesting than standard form is what we call general form. And we're going to get general form for all conic sections. And this is the general form equation for all conic sections. ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. How about that? A, B, C, D, E, F. That is the general form equation for all conic sections. Ellipses, hyperbolas, parabolas, lines, points, everything can be expressed using that equation. In the case of a circle, A and C must both equal 1 and B must equal 0. Now, actually, A and C, if they don't both equal 1 but they equal each other, we can divide through by a constant, whatever that value is, to make them set them equal to 1. So actually, it's good enough if just A and C are equal to each other, because we can divide through to create them to be equal to 1. Because A and C equal 1 and B must equal 0, there cannot be an xy term. We could simplify the equation to x squared plus y squared plus dx plus ey plus f equals 0. Once we have that, now we can go ahead and actually use that to convert back to standard form so that we can actually find the center and radius of a circle. And doing so requires completing the square. We'll do a lot of completing the square with conic sections. Let me just remind you very quickly of the process of completing the square before we get into the problem. If I have x squared plus 6x plus 8 equals 0, the completing the square process was a matter of moving the constant to the other side, and then we took half of the coefficient of x here. So half of 6 is 3, and we square it. 3 squared is 9. So we added 9 to both sides. And then this factored, because of that, into x plus 3 squared, because half of 6 is 3, equals 1. That was our completing the square process. Now, it's fine. We have an even number. When we have an odd number, it does get a little trickier. Minus 7x, I'm going to say, equals 5 right away. I'm just going to make something up. Half of 7 would be 7 halves. So we're going to get x minus 7 halves squared. But 7 halves squared is 49 fourths. So that's what I have to add to each side. And 5 plus 49 fourths would be 69 fourths. Because 5 is 20 fourths. So we can do it with even or odd numbers. We can complete the square pretty easily. That's the process we're going to use here a lot. So if I'm given the equation x squared plus y squared minus 10x, what I'm going to do is I'm going to regroup it. I'm going to say, okay, x squared, I'm going to grab the other x term, minus 10x, okay, and then plus something, blank, plus y squared, plus 4y, plus something, blank, and move the 17 to the other side. All right, so we're going to group it. We're going to put our x terms together with a blank so I can complete the square, the y terms together with a blank so I can complete the square, constant to the other side. Now we ask ourselves, what's half of negative 10? Half of negative 10 is negative 5. So that's going to be x minus 5 squared. And negative 5 squared is 25. So we're going to add 25 to both sides. What's half of 4? 2. So that's going to be x, or y, excuse me. Sorry, I already had the plus there. Getting ahead of myself. Y plus 2 squared. 2 squared is 4. So I'm going to add 4 to both sides. And negative 17 plus 25 is 8, plus 4 is 12. So I've done it. I've very quickly switched to standard form. Center is at 5, negative 2, opposite of those. Radius is the square root of 12, which I would express as 2 root 3. And that's my circle. We simply complete the square. We have to regroup the equation, x's together, y's together, leave the blanks to complete the square, and make sure when I add something on this side, I add it on that side. That's our process from going from general form to standard form. Let's look at another one. Problem? Go back. Let's look at this one. Now, it doesn't look very good to start with because I've got this 4x squared plus 4y squared. So we're going to have to make sure we get it in the right form. So I got to divide through by 4 first. I can divide through an equation by 4. That works. So x squared plus y squared minus 6x plus 4y equals negative 51/4. Now regroup it. X squared minus 6x plus blank plus y squared plus 4y plus blank equals negative 51/4. Well, half of negative 6 is negative 3. Negative 3 squared is 9. I'm going to add 9 to both sides. 9 is 36/4. Half of positive 4 is positive 2 squared. Positive 2 squared is 4, which would be 16/4. 36 and 16 is 52 minus 51. So my circle has center at 3, negative 2. Radius is the square root of 1/4, which is 1/2. Yeah. If they aren't both 4, it's not a circle. We'll deal with that when we get into ellipses and hyperbolas and that sort of thing. Tomorrow, Friday. Well, you've done the ellipses and stuff before, right? You remember those? X minus h squared over a squared plus y minus b squared over y minus k squared over b squared equals 1 is a standard form of an ellipse. And if you put a minus sign in there, it's a hyperbola. Right? Kind of. We'll get back to it again. Okay? Yeah, if these values are not the same, it's not an ellipse. If they're both the same sign, if it's a plus and they're different, that'll be an ellipse. If this is a minus sign and they're different values, or if it's just a minus sign, then it's a hyperbola. And we'll talk a lot about that. We'll talk about we'll spend a lot of time just talking about distinguishing what it is based on the general form. But if they have to be the same for it to be a circle. Find an equation of a circle that passes through 3 points. This is a tricky little situation when we do this. We're not giving you the center of the circle, but we're giving you 3 points on the circle. And I think the other, hold on, let me check something once. I think I put some additional notes on the other version of this lesson. I had 2 versions of this lesson. I might use this one. Okay, yes. I did put the notes on there. I meant to put it in this one too, but I didn't. I don't know why I have 2 versions of this lesson, but there, I'm fixing it. Okay. Basically, the way it works is this. We're going to take each one of these points and use it as an x, Why? Because I know my general form is x squared plus y squared plus dx plus ey plus f equals 0, right? So I'm going to take each one of these points individually. Say negative 2, 3 is one of them. That's going to be an x, and that's going to be a y. So I'm going to put that in here. Negative 2 squared plus 3 squared plus negative 2d plus 3e plus f, which we don't know, equals 0. Well, negative 2 squared is 4 plus 9 minus 2d plus 3e plus f equals 0. So 4 and 9 is 13, so negative 2d plus 3e plus f equals negative 13. There's one equation. Now we're going to do that again with the second point. 6 squared plus 5 squared plus 6d minus 5e, plus negative 5 squared, which is going to be the same as 5 squared, plus f equals 0. 6 squared is 36, plus 25 plus 6d minus 5e plus f equals 0. 36 and 25 is 61, so 6d minus 5e plus f equals negative 61. Now we do it for the third point. 0, 7. 0 squared plus 7 squared plus 0d plus 7e plus f equals 0. Well, it's a little easier. It's going to give me a 49 here, plus 7e plus f equals 0, because 0d goes away. So 7e plus f equals negative 49. Now we have 3 equations and 3 variables. Right here, right here, and right here. And I can actually solve those equations simultaneously. So I set them up. Negative 2d plus 3e plus f equals negative 13. 6d plus 5e plus f equals negative 61, and 7e plus f equals negative 49. Those are my 3 equations and 3 variables. Now we have to solve that system. Yes. Sorry, it's negative 5. You're right. That could be a problem later on. Good. Good catch. Thank you. Now we have to solve that system. How do we solve that system? By eliminating variables. Now, this equation already is missing a d. So I can use these 2 equations to eliminate a d. And then I'll have 2 equations and 2 variables, and that makes it a little bit quicker. So I'm going to take this equation times 3 plus this equation. So first equation times 3 is going to give me negative 6d plus 9e plus 3f equals negative 39. And the second equation, 6d minus 5e plus f equals negative 61. When I add them, the d's cancel out. I get 4e plus 4f equals negative 100. And I can reduce that to E plus F equals negative 25. I can divide through by 4 and get E plus F equals negative 25. Now I'm going to take that result and combine it with this. So I'm going to multiply this one of them by negative 1. I'll keep this one, 7. So we're going to take 7E plus F equals negative 49. Multiply this one by negative 1, so negative E minus F equals 25. And I get 6E equals negative 24. So E is negative 4. Now I know E is negative 4. I can back substitute that. E plus F equals negative 25. So F must be negative 21. Now I've got E and F. I can substitute into one of these equations to find D. You remember this process? It's long, isn't it? It's not hard, but we got to be careful. So let's take the first one. So negative 2D plus 3 times E, which is negative 4, plus F, which is negative 21, equals negative 13. So 2D, or negative 2D, excuse me, negative 2D minus 12 minus 21 equals minus 13. That's minus 33, so negative 2D equals 20. So D equals negative 10. And I substitute those back, and I just go back to this. The equation of that circle is x squared plus y squared minus 10x minus 4y minus 21 equals 0. I know D, E, and F have got the equation of that circle. That was fun. Yeah. Is it? No, because this is a positive 20. Because I get negative 33, I add 33 to each side, we get positive 20. Negative 2D equals positive 20, so D is negative 10. Let me go back all the way up here to our original equation with D, E, and F and substitute in it, and that's the equation of our circle that has those 3 points. Yay! Okay, slow and tedious. It's not a lot of that in the homework, but it's excellent algebra work. Excellent computational algebra. It takes time. So you have to do 3 different substitutions in, creating 3 equations in 3 variables, do my elimination steps until I solve for 1. Oh yeah. Now we're having fun. You remember doing that stuff, I'm hoping, somewhat? Kind of. I hope so. If not, we'll practice it a little more. All right. So your assignment, which I do not have on the assignment sheet yet, but I have, we'll work on that next hour, is page 529. Number 5, 9, and 15 through 36 multiples of 3. So 15, 18, 21, 24, you get the picture. And we just take a quick look at that. Stats, pre-calc. On 529, goes on to 530. You have 2 of those problems where I give you the 3 points and you have to find the equation. 27 and 30. Okay? Just 27 and 30. Those will be the long ones. The rest of them should be pretty straightforward. All right. There we go. Happy Wednesday. And look at it this way. Only 7 more first hours before spring break. Unless, of course, you're leaving early. And Monday's late start. Well, not for me.